The Safe-Lok ground fault interrupter, or GFI, receptacle is designed as a safety measure to mitigate the risks associated with the incorrect wiring of electrical receptacles. However, it is crucial to understand that while it offers a degree of protection against miswiring, it is not an infallible solution. In scenarios where the line and load wires are inadvertently reversed during installation, the receptacle might still appear to function, providing power to connected devices. Despite this apparent functionality, a critical safety feature, the ground fault protection, is compromised and rendered ineffective. The underlying principle of GFI protection hinges on the correct and specific connection of both the line and load wires to their designated terminals within the receptacle. This correct connection establishes a complete and functional GFI circuit. This circuit is meticulously designed to continuously monitor the balance of current flowing between the line and neutral conductors. In normal operating conditions, the current entering the receptacle through the line wire should precisely equal the current returning through the neutral wire. However, if a ground fault occurs, meaning that a portion of the current deviates from its intended path and flows to ground, an imbalance is created within the GFI circuit. This imbalance, even a slight difference in current, is immediately detected by the GFI, which then swiftly trips the circuit, cutting off the power supply and thereby preventing potential electrical shock or other hazards. When the line and load wires are reversed, this carefully calibrated GFI circuit is disrupted. The reversal effectively breaks the continuity of the ground fault detection mechanism. Consequently, the receptacle loses its ability to detect any current imbalance caused by a ground fault, leaving individuals vulnerable to electrical hazards. To ensure the correct functioning of the Safe-Lok GFI receptacle and to guarantee the availability of ground fault protection, meticulous attention must be paid to the wiring connections. The line wires, which carry the incoming electrical power, must be securely connected to the terminals clearly marked with line or L. Conversely, the load wires, which extend the circuit to downstream devices or other receptacles, should be connected to the terminals designated as load or alone. This distinction is paramount. Accurate identification and connection are essential for the proper operation of the GFI. Should there be any uncertainty regarding the correct wiring configuration, it is strongly advised to consult a qualified electrician. An electrician possesses the expertise and tools necessary to accurately identify the line and load wires and ensure their correct connection to the GFI receptacle. Furthermore, regular testing of the GFI receptacle is recommended to verify its proper functionality. Most GFI receptacles are equipped with a test button that simulates a ground fault, allowing you to confirm that the receptacle trips as expected. Pressing the test button should immediately interrupt the power supply, indicating that the GFI protection is active and functioning correctly. If the receptacle fails to trip when the test button is pressed, it may indicate a wiring problem or a malfunctioning GFI unit, necessitating further inspection and possible replacement. Remember, ground fault interrupters are critical safety devices designed to protect against electrical shock. Understanding their functionality and ensuring their proper installation and maintenance are crucial steps in maintaining a safe electrical environment. Regular inspections and testing can help identify and address potential issues, providing peace of mind and preventing potentially life-threatening electrical hazards. It is important to understand that electrical codes and regulations vary depending on the specific location. Therefore, it is always advisable to consult with local authorities or qualified electricians to ensure that all electrical work complies with the applicable standards. This proactive approach will help maintain a safe electrical system and prevent potential hazards. The proper functioning of a ground fault circuit interrupter, or GFCI, relies on its ability to detect minute differences in current between the hot, or line, wire and the neutral wire. This difference in current is a key indicator of a potential ground fault, which occurs when electricity strays from its intended path and flows through an unintended conductor, such as a person's body. GFCIs are designed to trip, or interrupt the flow of electricity when this difference exceeds a certain threshold, typically around 5 milliamps. This rapid interruption of power can prevent serious injury or even death. When the line and load wires are reversed on a GFCI receptacle, the device may still appear to function normally, providing power to plugged-in devices. However, the ground fault protection mechanism is effectively disabled. This is because the internal circuitry of the GFCI is designed to monitor the current balance between the line and neutral wires connected to the load side of the device. When the wiring is reversed, the GFCI is no longer able to accurately detect ground faults occurring downstream from the receptacle. To properly install a GFCI receptacle, it is essential to correctly identify the line and load wires. The line wires are the incoming power source and are typically connected to the terminals marked line or power. The load wires extend the circuit to other outlets or devices and are connected to the terminals marked load. These terminals are usually located in the back of the receptacle and are clearly labeled. It is also important to note that some GFCI receptacles are equipped with a self-testing feature, which automatically checks the functionality of the device at regular intervals. This feature can help ensure that the GFCI is always ready to provide protection in the event of a ground fault. Regular testing of GFCI receptacles is recommended even if they have a self-testing feature. This can be done by pressing the test button located on the front of the receptacle. The receptacle should trip and the power should be interrupted. If the receptacle does not trip, it should be replaced immediately. Ground fault circuit interrupters are an essential safety device in any home or workplace. They provide protection against electrical shock and can save lives. Proper installation and regular testing are crucial to ensure that GFCIs are functioning correctly and providing the intended level of protection. In addition to ensuring correct wiring, it is also important to select the appropriate type of GFCI receptacle for the intended application. There are several different types of GFCIs available, each designed for specific uses. For example, some GFCIs are designed for use in wet locations, such as bathrooms and kitchens, while others are designed for use in outdoor applications. Choosing the correct type of GFCI receptacle is essential for ensuring that it will provide adequate protection in the intended environment. Furthermore, it is important to be aware of the limitations of GFCIs. While GFCIs provide excellent protection against ground faults, they do not protect against overloads or short circuits. Overloads occur when too much current is drawn through a circuit, while short circuits occur when there is a direct connection between two conductors. Both overloads and short circuits can cause fires, and they require separate protection devices such as circuit breakers or fuses. Understanding the capabilities and limitations of GFCIs is crucial for ensuring electrical safety. By following proper installation and testing procedures, and by selecting the appropriate type of GFCI receptacle for the intended application, individuals can significantly reduce the risk of electrical shock and injury. It is important to remember that electricity can be dangerous, and it is always best to consult with a qualified electrician when performing any electrical work. In summary, firstly, ensure the line and load wires are correctly connected to the appropriate terminals in the Safe-Lok GFI receptacle. Secondly, regularly test the GFI receptacle using the test button to verify its functionality. Thirdly, understand that the Safe-Lok GFI receptacle is designed to prevent miswiring but is not foolproof. Fourthly, recognize that reverse line/load wires can cause the receptacle to function without providing ground fault protection. And fifthly, consult a qualified electrician if you have any doubts about the wiring or the proper functioning of the GFI receptacle. Correct wiring is crucial for effective GFI protection. The purpose of a ground fault circuit interrupter, or GFCI, is to protect people from dangerous electrical shocks. They do this by monitoring the current flowing in a circuit. Under normal circumstances, the current flowing to an appliance or device should equal the current returning. However, if a fault occurs and some of the current leaks to ground, such as through a person touching a live wire, the GFCI detects this imbalance and quickly cuts off the power. The key to understanding how GFCI works is the concept of current balance. The device constantly compares the current flowing in the hot, or line, wire with the current flowing in the neutral wire. If these currents are equal, the GFCI assumes that the circuit is operating normally. But if a difference of even a few milliamps exists, it indicates that some current is leaking to ground, posing a shock hazard. The GFCI then trips, interrupting the circuit and preventing injury. When a GFCI is miswired, specifically when the line and load wires are reversed, the device may still power the outlet, but the critical ground fault protection is lost. This is because the internal sensing mechanism of the GFCI is designed to monitor current flow on the load side of the device. With the wiring reversed, it's no longer able to accurately detect ground faults occurring downstream. The line wires, which supply power from the electrical panel, must be connected to the terminals marked line or power supply. The load wires, which extend the circuit to other outlets or devices, should be connected to the terminals marked load. Failing to make these connections properly disables the ground fault protection. GFCI receptacles typically have a test button that allows you to simulate a ground fault and verify that the device is working correctly. When pressed, the test button creates an imbalance in the current, causing the GFCI to trip and cut off power to the outlet. This test should be performed monthly to ensure the GFCI is functioning properly. If a GFCI fails to trip when the test button is pressed, it should be replaced immediately. Beyond simply testing, it's crucial to understand the different types of GFCIs available and their intended uses. Some are designed for general-purpose use, while others are specifically designed for wet locations or outdoor applications. Choosing the right type of GFCI for the environment is essential for ensuring reliable protection. Additionally, it is necessary to know the limitations of GFCIs. While they are excellent at preventing shocks from ground faults, they do not protect against overloads or short circuits. These types of faults require separate protective devices like circuit breakers or fuses. In the realm of electrical safety, ground fault circuit interrupters play a crucial role in minimizing the risk of electric shock. Their functionality depends on the correct wiring of the receptacle. When miswired, this protection is eliminated.